Hello again, everybody. This is Chris Mackey, and this is your sixth Ladybug Comfort Tools tutorial, and the second one in which we will be working with the psychrometric chart, which you see I have pulled up here from the last tutorial. So just a quick refresher. Remember in the last one we went over basically how to set up the psychrometric chart, how to hook up outdoor weather data to it, and how to define comfort polygons based on these various means of assessing comfort, and comfort parameters too that can do things like setting upper limits on humidity ratio. So now that you guys have a sense of that, now here becomes some more of like the more architectural design stuff that we can now start to take into account with this chart. And specifically, I'm going to show you a lot of the sort of ways of working with passive strategies and for selecting out certain periods based on outdoor criteria or other criteria in this video. So we're going to go and start and actually just to keep things kind of neat here, I'm going to make a whole copy of all this that we did the last time. Let's see, maybe everything down from the weather file, because I think, well, let's mix it up and just work with a new climate, I think, for this one. And we won't take that, and I'm just going to do a Control-C and then a Control-V in the Grasshopper window just to make a copy of everything. And it's gonna run through all the scripts again because I didn't set the psych chart to false or anything, but it should only take a few seconds. And in the meantime, well, actually, yeah, while that's working on that, let's go back to our weather database that maybe you still have open from the last tutorial. And I'm thinking for this one, because we're working with passive architectural strategies, I have a good feeling that I think this is going to be something really applicable to my girlfriend's hometown, which is the San Fernando Valley in LA. And so we're going to grab this Burbank file, which is probably the best approximation of the climate of the San Fernando Valley. And so we can just right-click on the zip and go to copy link address. And now if we go back to our Rhino window, hopefully it copied everything over. And so let's see, I'm going to drag this down so that we don't make things too messy. And I'm going to set this to run it to false on the psych chart. And let's see, and we're going to double click on this panel here and do a Control-V to paste in the web address of that Burbank file that we were just at. And then hit OK, and so then that's going to download the file and open it and bring in all the values in that file into Grasshopper for us. And then let's see, and now we don't want this to really generate on top of the other site chart, so let's find a point to move that. And for that we'll just use the native Grasshopper construct point component. And this, let's see, we'll move it up a little bit in the y-axis, so let's see, set number, and maybe we'll move it up 300 above, 300 Rhino model units above where we are. And so if you hook that to the base point, and then we will set the psych chart to run for true. Then we will get both, we'll keep our New York one here just for comparison, but we will get both New York and now above it, once my slow processor is happy, okay. Oh, actually maybe 300 was a little much, but all right, so we got New York down there, and then up here we have Burbank. Which you can see is quite a lot different. It's a lot drier. We don't get that 100% humidity. So I think it was a good idea to mix things up. So I'm going to turn the preview off on that point. Okay, so now let's get into those architectural strategies that I mentioned. And so we've already defined comfort as best we could in terms of people changing their clothing and stuff. So we have a component in Ladybug that's under the extra panel. And you'll see it's called the Ladybug Passive Strategy Parameters. And sorry, yeah, it's a long description because I give all the assumptions of each of the passive strategies in there. But I want you to grab this Ladybug Passive Strategies. Sorry, I didn't mean to say the parameters component. Let's put the parameters component away for now. We just want the Ladybug, the passive strategy list. We want the simple list. So drag and drop that strategy list onto the canvas. And you can see it gives us a few options that you can check and uncheck. For different passive strategies where we don't necessarily have to resort to air conditioning, that we can use some of these that would have a lot less energy associated with them. So for example, for Burbank, all right, well, it tends to be actually relatively dry, although it gets hot at sometimes. So to deal with these hot hours, let's see. I mean, well, if it's a dry climate, then it's particularly good for evaporative cooling. So let's check that one. Maybe we'll also, just out of curiosity, check thermal mass and night vent. Well, actually, no. I think it's better to go through them one by one, and I know it'll take some time, but I think it's worth it because you guys will get a sense of these. So let's just check evaporative cooling, and then you can hook this into the passive strategy input of the Psych chart. And once it does that, it's going to take a few seconds on my machine to draw because it's a slow little laptop of several years. But you should see the evaporative cooling polygon will be drawn on the Psych chart. Okay, here we go. So the thing is, evaporative cooling, which is essentially the act of using water and just having it evaporate, and that can cool down the space. So that will make these hours of the year comfortable. And the thing is, we can know the specific percentage by actually looking at our outputs of the Psych chart here. So the thing is, well, total comfort percent is 28, okay, but then we know that's mostly probably because of the major comfort polygon. But we can see the individual differences between evaporative cooling and that comfort polygon by looking at strategy percent of time. And you can see that this is a list of two values. So one of which is for that comfort polygon, and the other one is for the evaporative cooling. So evaporative cooling is really only getting us 1.5 hours comfortable. Maybe it's not really worth it. But you saw I just copied and pasted this panel. And it can help to sort of keep track of your strategies. I also give you strategy names. So you can say, oh, they're exactly what I told you, comfort and evaporative cooling. That correspond to each of these strategy percent of times. And by the way, and this also corresponds to, you get out lists of whether hours are in a strategy or not. If you remember from the last video, we plotted some of the, something similar to that. And those are also ordered according to the strategy names here. So let's try some other strategies. We can try, maybe evaporative cooling really isn't the best if it only gets us 1.5 hours. So let's check thermal mass and night vent. And again, it will take some time to draw this on my machine here. And boom, okay, and there we have a thermal mass and night vent polygon that's drawn now on the Psych chart, which you can see it isn't quite as limited along this line that has to draw back here in the way evaporative cooling is. So let's see, we get a few more hours that are comfortable because of that. Well, actually really not too much. It's still only about like 2%. So all right, so maybe those aren't the ideal strategies, but at least they're helping us. They'll probably help us eliminate the need for an AC probably for a large fraction of the year. Of course, if we could really move this humidity ratio up or down, I'm sure that we'd see a lot more of an effect from that. And as you knew in the last video, that could be an assumption. That can and maybe should be questioned and adjusted. But then all right, so we have thermal mass and night vent, but let's see, okay, all right, what about occupant use of fans? So again, that one is also going to take into account this upper limit on humidity ratio. But again, you'll see, in most particularly cool climates, maybe Burbank isn't the best example of this, but in a lot of cool climates, you can usually deal with your heat gain without having to resort to these somewhat more expensive evaporative cooling and thermal mass strategies. Okay, so you can see in this case that it doesn't really help us too much more. So it's so small that it's not even able to outline it. But I guess we get an extra 0.6%. So maybe fans aren't necessarily the best thing for the Burbank climate. But certainly the thermal mass would be in line, and probably with a lot of the historical architecture around there. If only because like Adobe and thermal mass are pretty well suited to the climate, and maybe that would be one of the better cooling strategies, perhaps combined with a loosening of the guidelines on this somewhat strict humidity guideline here. But one thing that we can do at least to deal with this. So one thing that I've sort of put in here, at least to deal with maybe these types of situations, if you really have to deal with a line of absolute humidity. is that I check this desiccant dehumidification, and that will actually grab a significant portion of the mesh faces that are in that upper region. And I find it to be particularly useful. And the thing about desiccant dehumidification is that it essentially uses a material that's a bit like here we go. See, so you can see it can grab a lot of different of that area. And actually, what does that end up being? It ends up being about 4%. And if that's a lot less than air conditioning, then maybe that's actually a pretty viable strategy for dealing with these somewhat humid conditions in the Burbank climate. So it essentially works though by having a substance that draws water to it, like those little packets that you'll find in like beef jerky that keep it from becoming too moist and degrading. So you have something like that, but you need to bake the water out of it somehow, and in order to be able to reuse the desiccant. And so maybe you could use some type of solar heat like that, but I guess the point is that it's not necessarily as energy intensive as full-blown compressor air conditioner. So we have that. Now lastly, I guess we have a huge chunk here that we haven't really dealt with our passive strategies. And so for that, we can rely on the internal heat gain, which basically means I'm going to check this right now. But that basically means that we're accounting for all the people, all the lights, all the solar gains, all the fact that all this heat can get trapped in the building if we close up our windows. And so the reality is that we don't really need to heat or cool during that time because we have these things in our building. And you see, if I check that, then we nab a whole bunch of extra times of the year, particularly when, I guess, probably more in the winter, I'm guessing, when that's happening. And you can see what percentage is that? That is a whopping 42%. That is a lot. And you can see all together, we're like, wow, we can get 75% of the hours of the Burbank climate comfortable with just these passive strategies without having to resort to air conditioning or heating and cooling. And maybe even, if these are the only hours that we're really worried about, maybe this isn't really enough to merit having to put in an air conditioning system. Of course, there are other sort of ways of trying to argue that, but this basically has walked you through all the individual strategies that you can apply and put on top of your Psych chart and then use to analyze the results. And as I said, you get a strategy or not, so you can plot that on the 3D chart just in the same way that actually, no, maybe that's useful. All right, I can fast forward it though. So I have, you see I still have the 3D chart from before, but I put some of my favorite parameters on it. And if you remember last time, so this should still be in the Rhino scene, just far away. Yes. So we have the hours that were comfortable in New York, essentially, with just changing clothing, which weren't too many. But now we can do something like taking the strategy or not output here and plugging that into this. And that's essentially going to then make us a chart for each individual strategy that we just plotted on our Psych chart. So you can see the times of year when these things are relevant. And I'm just going to fast forward because I know it's 5 charts and it's going to take a few seconds. Okay, so you can see that it generated charts for each of those strategies. So you can see specifically what these are here. So the comfort polygons, so just using clothing, those are the hours that are comfortable there. Let's see, comfortable hours, and with evaporative cooling, not too many, a few in August and September maybe. Same goes for thermal mass and night vent. And the real big saver that we saw here was the internal heat gain. That helps us mitigate most of the times of the year when we would need to otherwise try and heat the building or something. So you can get a sense then in this way of which strategies would be better and when in the year that they're helping. All right, so I'm just going to disable this for now. So that we can continue just to play around with the Psych chart as is without having it recalculate all those. So all right, and then to go back to our Psych chart for Burbank with all of our nice strategies on it. Okay, so now, but the thing is, you should be aware also that each of these polygons has some assumptions that are associated with it. And I'm going to say first off the bat that this is, I mean, the idea of plotting strategies on a psych chart is not very new. Certainly the one who really set the precedent is this wonderful tool called Climate Consultant that was the inspiration for this one. And the thing is, it's basically was meant to process weather data and do essentially the same thing that we did here, where you will toggle these strategies on and off. And sort of see which hours are comfortable. And this is, I mean, you can sort of see this psych chart as just a Python and Rhino Grasshopper version of this, where you can change a lot more things and you know, move this comfort polygon around and stuff. So I mean, but importantly also that this Climate Consultant allowed you to change all of these assumptions when you select your comfort model. So the model that was selected and that is used in the psych chart here is the ASHRAE standard PMV. And you have all these assumptions that Climate Consultant allows you to change. And you can do this too now with that parameters, passive strategy parameters component. And yes, and this is the one with the long description that says all of the assumptions. So just drop and drag that onto the canvas. And you can see there are a few key ones that I give you access to. I mean, it's not there. Well, some of the polygons seemed a little extraneous, or that will eventually work them in from what Climate Consultant has given you here with a bunch of different options. But these are meant for just the polygons you have here, so you can adjust things like the building balance point and the maximum comfortable airspeed for your occupant use of fans, or your certain parameters that are shaping this very large night flushing and thermal mass. And all that you would have to do is connect this up to the strategy part there. And so I mean, so that's another thing to keep in mind. I'm not going to run into this right now because I mean that's a more pretty advanced thing. But there is one more key thing that I want to show you before we sort of move on to the final sort of things we do with the psych chart, in which we're going to do energy simulations. So all right, so I'm just going to delete this for now. I just wanted to let you guys know that it's there. But the last things now, we're coming down to the last things here that you may already, if you're a normal Ladybug user, you might already be familiar with a lot of these things. But things like analysis period, so you don't necessarily need to plot the entire year on this chart. You can plug in an analysis period using the Ladybug analysis period component that I dragged down from there. Or now the one that I'm really going to show you that can be pretty powerful is annual hourly data with a conditional statement. So let's say, I mean, so there's an assumption here. All these passive polygons are all sort of assuming that that you're naturally ventilating, I guess, that you allow occupants to open windows and sort of, in order to be able to count these as strategies, and or at least in order to say that the outdoor air that we're looking at here is a meaningful thing for our comfort analysis. So the thing is, something that might be very important for that is the wind speed. So if you're not able to get enough wind into your building to say in order to release some of these, or say to night flush your building, then maybe it's not too worth it. So in order to address this, you can do something like taking the wind speed and plugging it into the annual hourly data input of the psych chart. And so this is the wind speed from the weather file. And what this will do, we'll see in a second, is that it will just coordinate everything that's on the psych chart with the wind speed. So you won't necessarily see a big change at first, but I'm going to show you some awesome special things that we can do to kind of show you how you can account for wind speed or express wind speed on the psych chart. Okay. So the thing is, so you get out these points, and you remember before that they were displaying, and I turned them off because we wanted to see this colored mesh. But so if we don't want to see the mesh right now, if we actually want to use those points, we can preview this off. So right click and hit preview on the psych chart, and now it's just this that's displaying, just those things. And maybe we actually want to disconnect the legend here because I'm going to show you something cool in a second. Just bear with me. But the thing is, now we get these points for each hour of the year. And if you remember what they looked like from before, you essentially can hook up a grasshopper point component, and you see, okay, these are each individual hours of the year on the psych chart. So you can get really finely detailed and understand what's going on there, not just as the mesh. But the thing is, what would be really cool if, say, now we can take these points and color them with something that we connected here, like the wind speed. And that's exactly what comes out of the point colors. So the things, but you notice you get two lists here. So actually one list is actually a comfort or not list. So if I grab a grasshopper preview component, we can sort of get a sense of this. And I'm actually going to delete this point one right now and just hook up the points as the geometry to the preview component. And then let's just select one of these lists. And you can use the native grasshopper branch. Let's see, we want the tree branch that retrieves all items in a specific tree branch. So with that, we can hook up our point colors, and we'll just hook up. So right now it's set to 0, so it's just selecting the first list. But let's we want to be able to select both lists. So let's hook up a slider. If we just type 1, I think yes, that'll be a slider for 0 and 1. So let's hit 0 for now, because actually that'd be kind of nice to keep it like that. And then hook that up to the swatch of the preview. And you see, okay, it's coloring the points with our comfort, what's inside the comfort or not. And so that can be useful sometimes in certain respects, especially for the thermal mass and night vent, where it can be inside the polygon and it might not necessarily still be actually good enough for you, because it doesn't meet some of those assumptions I showed you before. But now you can also turn this to 1 to the second list, and you see it's coloring the points with the wind speed. And so you can get a sense, okay, what are the times of year? Well, actually, thankfully, it looks like there's higher wind speeds at the times that we really need it to help us cool. So that's a pretty nice thing to discover there. And the thing is that if you need the legend that corresponds to this, that actually comes out of this hour point legend right here. So there's no legend on the side, but we can Control C and Control V on the tree branch here and hook up the hour point legend, and then you will see, boom, there is the legend for the wind speed in meters per second. And you can, of course, adjust this with the legend par and so on and so forth. But essentially, these are the wind speed values that correspond to these colors. And as a final thing, many of you probably already know this if you've been working a lot with Ladybug, but you can put in a conditional statement. So let's say it's only really worthwhile for me to look at points where the wind speed is greater than 1 or something. It's because I need that in order to, say, remove heat from the building at enough of a rate. So you can double click and you can do, let's see, a conditional statement such as, well, first I'll hit the quotation marks to start a panel, and I will do, let's see, we have to do C, because A and B in this case are temperature and humidity. So we have to do C is greater than 1. And then hit enter. And that's our conditional statement that we need here to say that only give me points where the wind speed is greater than 1. And so if you plug that now into our Psych chart, finally you will see at last it will display now the points where just the wind speeds are greater than 1. And you can also notice that, if you were to turn the mesh back on, that the mesh is also only for the hours of the year where the wind speed is greater than 1. And so you can imagine you can usually use, and this is very powerful, you can use this with any sort of connected hourly data. And it actually looks like, wow, that didn't seem to really take too many points away. Well, we can let's see, maybe if I turn the preview off on the points and, preview off, and then turn the preview back on the mesh here that I had, you can see, okay, the mesh, and I don't know if we really lost too many hours actually. It gets a lot of our major ones. So then maybe it's good for natural ventilation, or at least the night flushing that we had discussed earlier. But so this gives you a sense of all the kinds of passive strategies and the sort of conditional statements and awesome stuff that you can do with EPW data. And in the next video, we're going to be looking at the final stage of how to use the Psych chart, which is with energy simulation results, to sort of play around with different values for set points and such. So look forward to seeing you in the next video, and thank you.